Thank you very much.
Yeah, I have a guest speaker today. So Frank, he's covering sales within Pure and Portworx. So he will say some introductory words, and then I take over.
Great, thank you. So everybody is
and
running out right now, right?
Yeah.
So
the doors are locked, no chance.
Yeah, but anyway, great day to talk tech, right? It's raining, it's dark. Everybody is happy to talk a bit tech. Okay. So as you already mentioned, I'm a field rep, so I'm in sales. So everybody who wants to leave now, please leave. Yes, but. As we have a tech talk, we just discussed what's happening in the manufacturing industry. And as I'm a rep within Portworx, respectively for Pure Storage, I deal a lot with manufacturing customers. And I just want to give a few insights on what I am talking about with customers, especially what I heard during the panel discussion. Sometimes I feel like Babelfish to translate between those new techs and old or legacy tech. And maybe you can start with the next slide.
Yep.
Okay. So just one question. What do you think, besides the wedding rings, how old this slide is? Just a big guess. 1 year, 2 years? 5? More. Give me more. No, that's too much. Okay. Because there's Kubernetes on it, right? So it's happy birthday and so. But it's about 10 years ago, I got this slide in the slide deck, where they said, okay, let's separate the legacy slow tech, so the line above with Oracle, SAP and stuff, completely from the underlying evolving tech. Because this is what it is. Gartner says it, IDC says it, separate it. But from what I know, and when we talk to customers, there is nothing anymore that's getting separated. It's getting tied together with wedding rings, because we are not only talking stateless, as we heard a few minutes ago, but we are already talking stateful applications. And when you talk stateful applications, you talk data management platforms. And Pure Storage and Portworx, we provide data management platforms for customers to not only build new things in their production environments, but only to secure data, to address backup requirements, to address data DR requirements, and everything related to data. And this is what Daniel is going to talk about in the next few minutes. Everything regarding architected once and run it everywhere. So if it's on premises, if it's in the cloud, if it's in hybrid environments, I think we have the right solution to address these kind of requirements. So, Daniel, for you, well, this is just
one more.
Well, well, AI. Anybody heard about AI right now? But one thing, maybe one thing is interesting. I think I heard it about those things, cameras on the shop floor in production environments. This is driving a complete change in how production environments are utilized. So 100% quality control is one of these things everybody is talking about. And this needs a lot of bandwidth, a lot of storage, and a platform who is able to provide these services without any hardware, or that's hardware agnostic in the end. Because sometimes, like in China, you don't want to put your stuff into the public cloud there, but you need to ship it anywhere, you have on-premises requirements. So this is what we, with Portworx, provide you with to operate safely and securely. Thank you, Daniel.
Okay, I'll take over. So let's quickly, so we are mainly focused on storage in Kubernetes. Let me quickly talk about the idea of storage within Kubernetes and what we see in customers' journeys. So usually when customers go onto Kubernetes or containerization at all, there might be an expectation at the management level that in a linear amount of time, we put all the new applications to this new fancy platform because this is highly productive and we are all now Silicon Valley style. Well, the reality you might already know looks a little bit different. It takes some more time to migrate stuff to these new platforms or to replatform or to reinvent them. From a storage perspective, we usually see 3 phases. customers are going through. So the first phase is stateless. Yes, everyone knows Kubernetes is stateless, applications are stateless, so why don't you use them at all when they're stateless? But from a storage perspective, this usually means data isn't being stored within the Kubernetes cluster. So data comes from the outside, gets processed from a containerized Kubernetes managed application, and then this data is pushed out to another platform, another thing. So this is usually the first phase. In this phase, customers learn how Kubernetes is working, how containerization is working, integrate their processes, do day two operations, all these pieces. So lots of things to learn and to understand, no time to care about storage. But then usually customers go into the second phase, and this is non-critical stateful workloads. Your platform teams, your developers, your consumers might have realized that Kubernetes is a great thing to work with, that they can standardize, automate, all these things. And they might request that they now need storage, persistent volume claims, because the developer does not want to wait any longer to get a MySQL database being provisioned in a virtual machine, discussing with the VMware team to get the VM, discussing with the application team to get the database, and then discussing with the networking team to get network access from their Kubernetes application to the database running in a VM. They just want to deploy the database within the Kubernetes cluster as part of their application. So this is the second phase, where customers usually start with persistent storage, with persistent workloads in Kubernetes, and they will find out that any Kubernetes distribution platform cloud has already a solution for storage. It's a CSI driver. If you're running on AWS, on Azure, on Google, you have a CSI driver for their storage. If you're running on-premise, you might have a CSI driver from the storage vendor of your choice or within the Kubernetes distribution of your choice. And this might be good enough for the second phase. So developers start deploying applications, developing applications, stateful applications within the clusters. But it gets interesting when the third phase starts. So now as these applications get into production, people start questioning things. And it's about how does it look for, how's high availability for the storage being achieved? What's our disaster recovery strategy for this storage? What happens if the Kubernetes cluster goes down or if the cloud region goes down? We are in the cloud. How is our data protected? Is it encrypted? How can we encrypt it? Is there any protection for the data to prevent unauthorized access to this data? And by the way, what about backup and restore? So this is all questions which might arise in the third phase when these applications get critical, get business relevant. And this is usually the part where Portworx comes into the game. So taking out a little bit this journey of customers in Kubernetes, it usually starts with a single Kubernetes cluster. So maybe on-premise, Rancher, they use a storage system they already have. By the way, Pure is a great choice. And they deploy a database on top of this and run their applications. And if this is successful, this single team which implemented it, it's like 15 years ago Linux in the data center. It's something which happens under the desk secretly, and now it's successful, it works. And when this is successful, other people start jumping onto this platform and demanding also a Kubernetes cluster. And this might mean that they deploy in the public cloud or use another storage vendor with another cluster on top. And if this is all successful, it usually ends up in having multiple Kubernetes platforms. By the way, Kubernetes can help there. And running on multiple platforms, so on multiple infrastructure platforms. And this might become an issue when this gets into production and gets into scale, because you now need to manage different ways of storage, different technologies underneath, different capabilities with no interoperability, no way to migrate data from one cluster to another one, no unified way to manage this storage out of the Kubernetes layer. And this is what we address. So we can help you, at least in this level. We can help you manage, maintain, and run storage natively in Kubernetes, independent from the underlying infrastructure layer. And what are the issues we usually see in these inbuilt infrastructures? So there's the CSI connector approach, so this driver model to attach storage to Kubernetes clusters, who everyone is using to attach storage to Kubernetes clusters. So we see many customers starting with an on-premise environment and attaching their storage array to the Kubernetes cluster. And this works very well in this second phase of we are trying this and developers are testing and working a little bit on this. But it might fail in the third phase. Let me give you an example from one of our customers. Portworx customers. Usually these CSI drivers have a one-by-one container volume to storage volume mapping. So this customer ran an environment with 100 volumes, and he wanted to do a test, a scaling test, an automated scaling test. So the test was taking this deployment with 100 volumes and scaling it up to 2,000 or 3,000 volumes to see if this application can scale, because Kubernetes is built for scale. The customer started this test. It was an automated test. It failed for another reason. They fixed this reason and restarted the test 5 minutes later and retried, and then everything failed. And then they did a root cause analysis and checked, okay, what was happening there? And the problem in their environment, they had a CSI driver directly connecting to a storage array, and this storage array hasn't yet finished creating the first 2,000 volumes and did not remove them and did not start creating the next 2,000 volumes. And the key learning of this was storage systems are not built for scale in metadata operations. They are built for bandwidth, for low latency, but not creating thousands of volumes within minutes or seconds. And this was one learning of this customer. Another learning, by the way, was storage systems usually don't have rate limiting on their management APIs, which is quite interesting if your Kubernetes cluster throws thousands of API requests to the storage array to create volumes. You might fail. You might fail at scale. This does not happen if you're not scaling. Another problem we've seen is container or platform capabilities vary depending on the capabilities of the underlying array. This means each CSI driver is different. If you have different CSI drivers in your environments, there are, for example, differences if they actually implemented snapshotting. They don't need to. It's not part of the standard. And even if they do, there might be annotations depending on the platform you're running on, which enable capabilities or do not enable capabilities. And for you as a platform team, this means you need to maintain each of these separate environments and lifecycle them, qualify them, check them, update them, all these things. Storage looks different depending on the underlying architecture. Now think of the idea of Kubernetes. It's abstraction, it's standardization, and on top of this standardization, you have automation. Isn't it stupid to have a dependency to a storage system? Just asking. In the network area, no one discusses about the necessity of having a software-defined network on Kubernetes, no longer being dependent to hardware. On storage, many people do. And this leads to the last point here. Storage arrays are managed independently from Kubernetes. Did any one of you Kubernetes people, I guess, try to discuss with your storage people about your Kubernetes CSI drivers? Can be hard, because storage people usually don't know about Kubernetes. And Kubernetes people don't know about storage systems. Now think of having a piece of driver from your storage vendor being handed over from the storage team to you, and you need to run it. What happens if this fails? Who's responsible? The storage team? You? Do you know who to call? This is a part which needs to be discussed in this third phase of the adoption. And another point, this is the process part, but there's also a technical part. Now think of you have a dependency from your Kubernetes cluster to a storage array. What happens if the storage array software gets upgraded and the CSI driver needs to be upgraded? Is this new CSI driver compatible with your Kubernetes version you're currently running? Or will this become one of these weekends we all know about? There is no weekend, that's just work, updating and patching, and next Monday won't be funny at all. This is all pieces which led to the idea that Kubernetes needs another approach for storage. And this storage needs to be scalable, which doesn't need to have a dependency to any hardware array or hardware platform underneath. And this led to the development of Portworx. So Portworx is a storage system running natively in Kubernetes, built for scale, built for consistency, so it's no longer depending on the underlying infrastructure, which capabilities your storage system in Kubernetes has or how it's been managed. And it's part of Kubernetes. It's managed as a native part of Kubernetes. It's controlled by an operator. It's controlled by YAML specs. You can fully integrate it into your GitOps pipeline. So we are the leading Kubernetes data platform, taking care about providing storage within Kubernetes, providing capabilities like disaster recovery or migratability of data between Kubernetes clusters, to protect these data with encryption or RBAC access, and obviously also to take care about backup and restore stuff. And the key here is we are independent from the underlying cloud, from the underlying infrastructure, and we support all the major Kubernetes distributions relevant in the market. So let's take a more customer example we've seen in the field. The customer started with Kubernetes in a data center. And Portworx was providing the storage layer within this Kubernetes cluster. And the customer was running stateful workloads on top of this cluster. And now they decided to bring Kubernetes also to edge locations, so production locations. We have many customers currently running IPCs close to production lines, running a vSphere environment. And within this vSphere environment, they have a Windows machine. And inside this Windows machine, there's an application controlling some production machinery. And they decided to bring this into another platform, to a native Kubernetes platform. And they decided to run this on a bare metal Kubernetes cluster. So they rolled out these edge clusters, which is bare metal nodes with hard disks inside or SSDs inside. We can leverage to build a storage platform within this cluster. And they did an initial deployment of data which is already existing in the data center and use Portworx to migrate or copy namespaces and their persistent volumes, persistent workloads, to this cluster. By the way, this customer also decided to rip out the virtualization layer completely and to run on KubeVirt, and we can support both. So for Portworx, a KubeVirt VM and the data this VM needs, so the disks, is just another PVC. And we can do the same stuff we do for native containers, also for VMs. So here in this example, they were using Portworx to do the initial migration of the data to the production line. And they also implemented our disaster recovery, async, to have a backup of the data back in the data center. So in case this whole cluster here fails, because it's one of these hardware appliances where you can put 5 servers into, and this is one array or thing. And it could happen that this fully fails. And for this case, they need a copy of the data which is changing here and running here in their data center to be able to redeploy or to take over production here in this area. So this was one of their first steps they did. And then they decided, okay, this went well. Let's start with another location here or another deployment. And they were just deploying a second edge, which was also a bare metal environment, just running a plain Kubernetes environment and then also doing the initial migration of the data to this edge. Here they decided not to do async DR back. And finally, they also decided to have a failover from the on-premise data center to the public cloud. So now they are able, if in case of the data center is failing, to run all their production workloads in the public cloud in an k8s cluster. And this was the point where also encryption came in. So with Portworx, you can manage encryption for volumes on the Kubernetes storage class. And especially in the public cloud, this was a relevant thing for them. The benefit here was all storage is being done by Portworx. It's running locally in each of the clusters, and it's being managed Kubernetes natively. So all these deployments were managed using a GitOps approach. They got enterprise data protection and encryption capabilities in each of these environments, independent of the underlying infrastructure or platform. So this is bare metal servers with hard disks or SSDs in it. This is public cloud. This is a data center running on vSphere, I think. And last but not least, they have this unified operating model. So storage now looks the same in each of these environments, and it can be scaled like any other Kubernetes workload. So if you want to try this, we have a hands-on lab session on 16th of October. You can reach it on this URL, or you take a photo of this QR code. We also have this on our booth out there, so if you want to visit us and get some coffee mugs, please feel free. Any questions from you? No questions? All is clear? Yeah, one question, thank you.
Well, it's
I can also repeat the question. So.
Sure. Ah, cool. Thanks. There was an interesting demo in the morning where someone said, storage is like a flash storage. What do you think about that?
Storage is like a flash storage?
Like a flash disk, like you're going to use a USB and putting it in your PC. He said there's a comparison between a PVC and a flash disk.
So,
and it has the same problems. USB stick.
So you want to store your data on USB sticks?
He compared it like that, yes. What do you think about it?
I don't get the question, so...
Do you have the same problems, for example, when you're using USB stick, and you're putting it in your PC, and you're going to put your storage, your database, for example, on the storage. Has it the same problems like a PVC? For example, sudden data loss, consistency, for example, damning, stuff like that. So, what do you think about that?
So if you're running a PVC, which is provided by Portworx, we can provide redundancy. Over these, I had this on the slide with the bare metal. So here we have bare metal nodes, which with just SSDs or disks in it. We build a redundant storage system over them. So if you're running a PVC on top of this, which is being consumed by a database, this is high available.
Thought so also, thanks.
Yeah.
That's all.
Okay.
Another question would be, are you providing, for example, disks on the Kubernetes cluster? So for example, you're using the underlying CSI to create a disk, attach it to the nodes, for example, and using your framework for that.
We don't use CSI-provided disks, so we consume block storage from the worker nodes. So our prerequisites is we need worker nodes having block storage. We can either help you to automatically provision this block storage if you're running on vSphere, on Amazon, on Google, on Azure, because in these four environments it's crystal clear what block storage on worker nodes means. It's a VMDK being attached to VM or EBS volume being attached to EC2. But that's our prerequisite. On the bare metal cluster, it's just empty disks or empty SSDs or empty LANs. We don't care.
So the whole technology is in Portworx, for example, for snapshots, for redundancy, for all of that, right?
All of this is being done in the software. And that's the reason why it's the same everywhere.
How can you compare it, for example, like, let's say, Longhorn?
Well, Longhorn is an open source software heavily relying on the iSCSI stack. So Longhorn is great for smaller environments. And it's also working if you're a Rancher customer, for example. Then you get commercial support. But what happens if you need to run beside Rancher another solution? We are the only solution in the market which officially supports all major Kubernetes distributions and all major platforms.
Wonderful. Thanks for the answer.
Okay. Any more questions? Yeah.
Can you talk about a licensing model?
Yes. It's being licensed by worker node. So we don't care about the size of the worker node or the amount of storage. It's basically the amount of worker nodes you have in your clusters that need to be licensed. So that's basically the license. Okay?
Yeah, okay. Maybe a more technical question. What if the block storage on the node fails? How does the software recover?
So you can choose which kind of redundancy you want to have for a PVC, and this is being managed by the storage class. So we can have a so-called replication factor of 1, 2, or 3. 3 is because of a best practice Kubernetes cluster consists of 3 availability zones. So if you have 3 AZs, we would create a copy in each AZ. And if one of the worker nodes fails, or the attached storage fails, we will detect this and just fail over to another node. So this happens in sub-seconds.
Does that also have to fail over, or will it stay on the same node?
Well, if the node goes down, it will be obviously newly created. And also, if we lose the storage of a node, then we know something is not working on this node. So usually we take down the whole node. Technically, we could say, okay, the disks are down, but this node is there. But usually this does not happen that often. A disk could go down, so a disk could crash, for example. And in this case, we would leave the worker node or the worker node up and also the consumer up, but we will provision a virtual device. So actually, the pod needs to be restarted. It will be reattached to a virtual device which is being fed from the other worker nodes. Okay. But we can handle all these kinds of failures. So this software is designed like any other Kubernetes software. Everything can fail at any time. Any more questions?
Just one thing, when you told about the use case where one of your
Yeah.
volumes and it crashed, and then we retried and it was not working well. How this Portworx is helping there? If we are using Portworx and we go in the same situation,
Yeah.
something like that, how it is working?
So with Portworx, take this as an example. So this could be LANs from your storage system still. But we don't create a LAN on the storage system for each PVC you have. We put our PVCs within these LANs. So these two physical LANs could keep up thousands of PVCs. So we don't directly interact with your storage system. We do with your storage system what everyone does. We fill data into volumes. But we do not create thousands of volumes in a short time within your storage system. Because storage systems are not built for that. So we are just consuming the storage they provide, like any other workload. And we abstract, we put this into a kind of overlay and use this just as a data storage.
Okay, and how we will decide that then, the size of the one where you will create more and more PVC?
So technically, we decide this. In the moment where you create a PVC in Kubernetes, we will choose which worker nodes of your clusters fit for this PVC. And if you, for example, say, I want a PVC with a replication factor of 3, we first of all know if you have a multi-AZ Kubernetes cluster. If you have, we will try to find one node in each AZ which fits for this demand. And we decide this on base of what's the load of these nodes, how much storage did we already provision, and all these things. So this happens in the background fully automatically. And then we choose these worker nodes and we create the physical representation of the PVC, so the PV, on these nodes. And then we also influence the Kubernetes scheduler because you want your workload to be close to your volume. And if you have a multi-worker node setup, not only the 3, we choose these 3 worker nodes and then we decide together with the Kubernetes scheduler to put also the workload on top of one of these worker nodes to have a data locality. If this is not possible because of the node taints or congestions, we can use any other worker node and we will virtually provide the volume on this node and the transfer will go over the network. So your workload can be deployed everywhere in your cluster. We try to use data locality for the best performance, but this is nothing we enforce. If you want us to enforce, you can also set this up. And in this case, if it's not possible, it will fail. So there are many ways to influence these scheduling decisions if you want.
Okay. And the last thing is, what are the disaster recovery scenarios for this Portworx if it is failed inside the cluster?
Yeah. So Portworx doesn't fail, or software doesn't have errors.
Everyone says.
Yeah, and obviously it is software, so it can fail. So within the cluster, Portworx itself forms a cluster construct. So if you take a look at how Portworx is working, it's running on each of the worker nodes, and these worker nodes form a cluster. They maintain a cluster quorum. And if for whatever reason this whole construct fails, we have these async DR. So if you have set up this async DR, this is a completely different Portworx cluster than this one. So they're independent, like the Kubernetes clusters. So in case if you want to protect from a failure of this whole area here, we have the async DR, which just synchronizes data to the other cluster, where you could then take over production if you want.
And does this also provide any kind of management dashboard if you have multiple clusters?
We have a software which provides a kind of dashboard. Yes, people often ask this, but the better message for all these people asking this, we are fully Kubernetes compliant. We provide Prometheus metrics and we have prepared Grafana dashboards, which is in most cases more useful in the daily operating. But yes, we also have a software which shows a dashboard with, oh, this is your 10 Portworx clusters. But if you want to know more, it's just a link to the Grafana dashboard then.
Is Portworx provisioning the VMs, the VMDKs, for example, the logical disk, or do you need to do it yourself?
Both.
Both. Depends, right?
But no, it does not. Yeah, it depends on what you want. So if your Kubernetes cluster is running on vSphere, Amazon, Google, or Azure, IBM Cloud, I think also, and Oracle, but no one uses this. But one of these 4, you can tell Portworx that this is running on vSphere, Amazon, Google, Azure, and you want each worker node, for example, contributing 100 gigabyte of EBS GP2. for example. Then Portworx would start and would attach 100 gigabyte of GP2 to each of the worker nodes of this cluster. And after it's finished, Portworx would see, oh, there's unused block storage on the worker node, and go on. So we can automatically provision. If you don't want this, or if you're running on a cloud like OpenStack, we don't support, it's on you to provide at least to amount of worker nodes this unused block storage. One benefit of automating this is day 2 operations. Because what are we? We are actually a storage system within Kubernetes. What happens first on a storage system? You run out of storage. So you can run out of this pool Portworx is managing over all the worker nodes, or your PVCs can be running out of storage. And we can react automatically on both. We have a component called Autopilot, which allows you to create a YAML spec saying, consuming our own Prometheus metrics, and saying if the usage of a PVC following a label, following a namespace with a label, so all the label game in Kubernetes, or if the pool is running out of storage, going above 80% usage, then extend it. And if we can provision this automatically, we can automatically increase the size of this backend storage or add additional backend block storages. If you don't have this capability because you don't want, that's not possible, but you can still do the resizing or the automated resizing of PVCs. And yes, you can set an upper level for the resizing of the volume, so you can prevent your users consuming all the storage you have.
Okay, are you using any features of the underlying storage systems, like, for example, snapshots on the network system?
No, because we are independent from the underlying storage. We really love to have pure storage underneath, but basically we don't care.
So it's just
Yeah.
a bunch of this.
We are just consuming block storage, like any other workload on your platform does. So you don't need to have a separate way of doing things for your Kubernetes cluster on vSphere, for example. It's just another workload. That's it.
And will there be a change in the user experience, how people are creating the PVCs? It's like right now they create the PVC and there is a storage class which is from AWS most probably, like EPS or something. So if I install Portworx inside the cluster, so when I would say the people using the platform, if they want to create the storage, they need to define some Portworx configuration.
No, they don't need, and that's the benefit here. We are just reacting as any other default Kubernetes thing. We are creating storage classes. So by the way, out of the box, we create some default storage classes, but you can create also your own, just referencing our provisioner, and that's it. So you will have just some storage classes provided by Portworx. That's it. Any more question?
Yeah, you said you rely on block storage for your own storage, but Portworx itself is also providing block storage for you?
Yes, so Portworx is providing block storage within the PVC to the workloads. But most of the workloads consume file storage, by the way. They don't consume block. So if you're running, for example, MySQL or Postgres, this is usually demanding a file volume. And we just provide this file volume to the workloads. But we can also provide block storage, and we can, out of the box, also provide read-write many.
And you're not relying on iSCSI in any way?
No. Because iSCSI has to, if you're relying, and this is one of the issues we can see, for example, for Longhorn, there's a maximum amount of iSCSI mounts you can have on a worker node. Now, if you think about scaling of thousands volumes, you might have an issue. Any more questions?
I think it's time
We're
to
done?
I mean, if there are no more questions.
Last slide, please.
Um,
If you want to dig deeper, just check out the hands-on labs, or just give us a call, or write an email, or LinkedIn, or whatever. So I think that was quite interesting, and thanks for everybody.
Thank you.
Thank you to both of you.